Hello, this is Tuğba Ayhan, and this video is about basic principles of PES transistor circuits. Assume that the soft node Vx voltage is equal to 0 initially. A logic 1 level is applied to the input terminal, which corresponds to VOH, and for this example, VDD. Now, the clock signal at the gate of this PES transistors goes from 0 to VDD at time 0. PES transistor starts to conduct as soon as the clock signal becomes active, and that MP will operate in saturation. So, this capacitance here, Cx, will charge up with the current through this transistor. This current is equal to ID, the drain current of MP, and also it is equal to Cx times dVx by dt. We can write the equation of ID, because we know that MP will be in saturation, as a function of Vx, Vin, and Kn and Vt0 of this MP transistor. Then we can solve this equation set to find Vx as a function of time. Then we will have this function here. As we can expect, the voltage level at this point is a function of VDD, Vt0 of MP, Kn of MP, and this capacitance value Cx. The maximum value that Vx can take is VDD minus Vt0 of this NMOS. So it can never reach to VDD. The PES transistor will turn off when Vx is Vmax, since at this point its gate to source voltage will be equal to its threshold voltage. Therefore, the voltage at node X can never attain full power supply voltage level of VDD during the logic 1 transfer. Here we see another example of logic 1 transfer. Now consider the case in which a logic 1 at the input node is being transferred through a chain of cascaded PES transistors. For simple analysis, we assume that initially all internal nodes V3, V2, V1 are equal to 0. The first PES transistor M1 operates in saturation because VDS of 1 is greater than VGS minus Vt0 of M1. Therefore, the voltage at node 1 cannot exceed the limit value Vmax, VDD minus Vt0 of N1. Now, assuming that the PES transistors in this circuit are identical, the second PES transistor M2 operates at the saturation boundary, so as M3 and M4. Regardless of the number of PES transistors in the chain, the node voltage at the end of the PES transistor chain will become one threshold voltage lower than VDD. This is a different case in which the output of each PES transistor drives gate of the next one. Here, the output of the first PES transistor M1 can reach the limit Vmax, VDD minus Vt0. This voltage drives the gate of the second PES transistor, which also operates in the saturation region. Its gate to source voltage cannot exceed Vt0 of N2, so the upper limit for V2 is equal to VDD minus VT0 of N1 minus VT0 of N2. It can be seen that in this case, each stage causes a significant loss of voltage level. Now we can go back to logic 0 transfer. Assume voltage level Vx is equal to logic 1, so it is equal to VDD minus VT0 of this transistor. A logic 0 level is applied at the input terminal, which corresponds to Vin is equal to 0 volt. Now, the clock signal at the gate of the pass transistor goes from 0 to VDD at t is equal to 0. Then, MP conducts, so the direction of drain current flow through MP will be from Vx to Vin. This means that the intermediate node X will now correspond to the drain terminal of MP, and this node Vin is the source terminal. Similarly, the circuit can be analyzed when MP is in saturation. However, as Vx drops down while the Cx, the capacitor, is discharging, the operation mode of this transistor will be linear. So we will find a more complicated function for Vx, but still if it will be a function of VDD, Vt0 of MP transistor, Kn, Cx, and of course time. We will get this curve. The voltage level at terminal X will drop from Vmax, which is VDD minus Vt, to 0. Unlike the charge-up case, the applied input voltage level, logic 0, can be transferred to the soft node without any modification. It means we can reach 0 volt at Vx. Charge storage and charge leakage. We will assume that a logic high voltage level has been transferred to the soft node during the active clock phase, and now both the input voltage Vin and the clock are equal to 0. The charge stored in Cx will gradually leak away due to leakage currents associated with the pass transistor. The gate current of the inverter is negligible for all practical purposes. We see that the leakage current responsible for draining the soft node capacitance over time has two main components, namely subthreshold channel current and the reverse conduction current of the drain substrate junction. We need to look at the transistor model. So we have this leakage current. It can go through the channel, so subthreshold current, or it can go to the bulk in reverse direction.